124 light-years from home, a distant world is sending us a message. It's not a radio broadcast, but a chemical signal, a molecule that, here on Earth, is produced almost exclusively by life. The James Webb Space Telescope might have just found our strongest clue yet in the search for aliens, but is it biology? Or are we getting ahead of ourselves? He question, are we alone? Has followed us through history, but now, it's not just for philosophers. It's a question for astronomers, chemists, and physicists, and their attention is locked on a mysterious world light years away. This is the story of Go2-18, a planet that shot to the top of our most wanted list in the search for extraterrestrial life. We're going to follow the clues, weigh the evidence, and find out what science really thinks about our chances of finding company in the cosmos. This isn't just another space documentary. Think of it as a detective story, and the mystery is one of the biggest of all time. Before we get into the evidence, let's meet our main character. K2-18b is an exoplanet, meaning it orbits a star that isn't our sun. It's about 124 light-years away, which, cosmically speaking, is practically in our backyard. It circles a red dwarf star, one that's smaller and cooler than our sun. Now, this is where it gets good. K2-18b orbits its star right in the middle of the habitable zone. You've probably heard it called the Goldilocks zone. It's that sweet spot where a planet isn't too hot, isn't too cold, and could be just right for liquid water to exist on its surface. And where we find liquid water, we might just find life as we know it. But don't picture a new Earth. K2-18b is a behemoth, weighing in at about 8.6 times the mass of our planet. That puts it in a weird category. It could be a massive rocky planet called a super-Earth, or a small gassy one known as a mini-Neptune. It whips around its star in just 33 days, so its year is less than a month long. For years, it was just another dot on a star map. But then, we aimed the most powerful space telescope ever built its way, and everything changed. Enter the James Webb Space Telescope, or JWST. Its real superpower isn't just taking pretty pictures, it's dissecting starlight that has passed through the atmospheres of distant worlds. As K2-18b crosses in front of its star, scientists can analyze the light filtering through its atmosphere to see what chemicals are there. In 2023, JWST delivered a bombshell. It confirmed carbon-bearing molecules like methane and carbon dioxide in K2-18b's atmosphere. Exciting, since those are basic building blocks for life. But that wasn't the headline. The telescope found a tantalizing hint of something else, a molecule that made scientists everywhere sit up and pay attention: dimethyl sulfide, or DMS. On Earth, DMS is a pretty solid biosignature. It's a waste gas produced in huge amounts, almost entirely by marine life, especially phytoplankton. To find even a whisper of it on a faraway world was a huge deal. For a second, it felt like we were looking at the first real evidence of life beyond Earth. The data pointed to the possibility that K2-18b could be a Hycean world, a hypothetical planet with a deep liquid ocean under a thick, hydrogen-rich atmosphere. Methane, CO2, a potential ocean, and the ghost of a biosignature. It was the perfect storm of excitement. The detective story had its smoking gun, or so it seemed. In science, big claims require big proof. And just as quickly as the excitement ignited, the scientific community started poking holes in the theory. The initial 2023 hint of DMS was very weak and overlapped with signals from methane, making it hard to be certain. Then came the cross-examination. Other science teams looked at the same data and weren't convinced, with some suggesting the signal was barely there at all. Follow-up observations in April 2024 with a different JWST instrument provided stronger evidence, reaching what scientists call a 3 sigma confidence level. That sounds great. It means there's only a 0.3% chance the signal is a random fluke. But for a discovery this massive, astronomers want to be even more certain, holding out for a 5 sigma gold standard. Shortly after, another analysis of the new data claimed there was no definitive evidence for DMS at all, showing just how intense the scientific debate is. Scientists also started questioning the premise. Is DMS only made by life? While biology is the main source on Earth, research from early 2025 confirmed that DMS can be produced abiotically without life, and has been detected in interstellar gas clouds and comets, casting doubt on it being an exclusive biosignature. The very idea of K218b as a habitable world also came under fire. Is it really a cozy Hycean planet? Or is it a gassy mini-Neptune with no surface for an ocean to rest on? Its huge size and thick atmosphere make it totally alien to us, and some experts argue it could have crushing pressures and a boiling magma ocean hidden under its clouds. That beautiful artist's impression of a water world could just as easily be a portrait of a toxic, uninhabitable gas giant. So, after all the buzz and the backlash, what's the verdict on K218b? The case is far from closed, and the evidence for life is tantalizingly unproven. That hint of dimethyl sulfide is still just a hint, clouded by noisy data and plausible non-biological explanations. This might sound like a letdown, but it's actually science working exactly as it should. It's a messy, exciting process of discovery, debate, and double-checking. K218b has forced scientists to sharpen their tools and their theories. It's made them question what a biosignature really is and confront just how hard it is to find life across hundreds of light years. The story of K218b isn't a failure. It's a critical chapter in a much bigger investigation. It showed us what to look for, but also how easy it is to be fooled. K2-18b might have been the prime suspect, but it's not the only person of interest. We live in a galaxy that's packed with planets. As of late 2025, astronomers have confirmed the existence of over 6,000 exoplanets, and that number is always growing. Based on what we've found, there are likely trillions of planets in the Milky Way alone. The investigation is just getting started. Our telescopes are constantly finding bizarre new worlds. Recently, the JWST gave us what might be its first ever direct image discovery of an exoplanet, a Saturn mass world called TWA-7b. It also studied the mind-bending atmosphere of a planet called PSRJ 2322-2650b, which orbits a dead star and has a unique atmosphere dominated by carbon. something never seen before. While these aren't top candidates for life, they prove we have the technology to probe these distant systems, and we're still finding promising worlds in habitable zones. The famous TRAPPIST-1 system, for example, has several Earth-sized rocky planets right where liquid water could exist. The main challenge: many of these planets orbit volatile red dwarf stars, which are known to blast their planets with deadly radiation that could strip their atmospheres away. That's why the hunt is now on for Earth-like planets orbiting stable, sun-like stars. The search for life probably won't be a single eureka moment. It's more likely to be a slow, careful process of elimination, of ruling out every other possibility until life is the only answer left. K218b wasn't the final chapter, but maybe it was the end of the beginning. It taught us that the universe is full of strange and wonderful worlds, and that the line between a chemical quirk and a sign of life is incredibly fine. We are the first generation in history with the technology to seriously search for our cosmic neighbors. The hunt is on, and the universe's biggest mystery is waiting to be solved.